This is part two of 6.6. We're still working on the distributive property. So I have a word problem here. I want to do one word problem. This is with distributive property. But then I also want to teach another part of it called factoring an expression. It's kind of like the reverse. Instead of distributing it, you're taking it out evenly. We'll get to that in a second. Let's do this one problem here. Each day, Martin, he lifts weights, and he lifts weights for 10 minutes. Okay, so he's lifting weights for 10 minutes, and then he runs for 25 minutes. I want two equivalent expressions to find the total minutes that Martin exercises for 7 days. Okay, so I could do, let's see, he does 10 minutes of lifting weights, and we want to know for 7 days. So I'm going to do 7 times 10. So that'll give me that. Okay, that's how much he lifts weights. But then I'm going to add it to 7 days times the 25 minutes. So this is lifting, and this is running. And it's for 7 days. So now I'm going to solve this. 7 times 10 is 70. 7 times 25, well, I know that 7 times 4 is 100. And 7 times, and then 3 more 25s is 75. So I'm at 175 there. Okay, and then I'm going to add these. When I do that, I get to, let's see, 45. Okay. So this is one way that I could figure it out. Another way is I could say, okay, each day he does 10 minutes and 25 minutes. So this is his lifting, and this is his running. So I can figure out what he does each day, and then I'm just going to times that by 7 days. And I could add these together, 35 times 7. And when I do 35 times 7, 35, let's see, 21, 22, 23, 24, equals 245. Okay. Or I could have distributed saying, okay, 7 times 10 is 70. 7 times 25 is 175, add them together. All right, so I solved this problem using distributive property. Let's go to factoring. The word problems get kind of tricky. You really have to think about it, and you really have to read them a couple times, underline some things, what's important, what is it asking for. It's tricky, but we take our time and we keep working at it, and you think about it, and you can get them. Okay, now, factor an expression. So you're kind of breaking it out. Instead of distributing this way, you're distributing it this way. If I have 9 plus 21, I mean, I could add that, it'd be 30, but I'm not going that way. I want to factor it. And when I see the word factor, I think of something called GCF. And this marker does not work. GCF. Greatest common factor. So I want to find the greatest common factor of these two numbers. That'll help me to factor it out. So I take the smaller number, 9, and I do my rainbow. 1, 9, 2, 3. Okay, those are my 3 factors of 9. Now I'm going to see which one. I'm going to start with the greatest and see if this is a factor of this one. Does 9 go into 21? No. Does 3 go into 21? Yes. So 3 is my greatest common factor. I'm going to put 3 right here, parentheses. How many times does 3 go into 9? 3 times. Plus, how many times does 3 go into 21? 7. Okay. So I factored this out. So 3 parentheses, 3 plus 7 parentheses, is the same as 9 plus 21. Because if I add these, 3 plus 7 is 10. 10 times 3 is 30. which we know is the same as 21 plus 9. I could do 3 times 3 is 9. 3 times 7 is 21. Okay? I'm factoring it out. I get the greatest common factor, pull it out, and see what I get. Okay, let's go to this one. See if this works. I'm going to take the smaller number, 56, and I do my rainbow. 1, 56, 2, let's see, 2 and 28. That's 3 going there. I don't think so. Does 4? 4, yeah, 4 and 14. Okay, does 5? No. Does 6? No. Does 7? Yep. 7 times 8. Okay, and then I know I'm done because there's no more numbers there. Okay, so 56 has a lot of factors. I got them all. Now, which one goes into 80? Does 56? No. Does 28? No. Does 14? No. Does 8 go into 80? Yep. There's my greatest common factor. So, I'm going to do 8 here. How many times does 8 go into 80? 10. Plus, how many times does 8 go into 56? 7. So, factoring this out, it's 8, parentheses, 10 plus 7. So it could be 8 times 17 is going to get me the same as 80 plus 56. Factored it out. Okay. Now, we can do this with variables too. So if I have 16 plus 4x, the x has to stay with the 4, but I'm just going to look at the numbers. So I have a 16 and a 4. I take my smaller number, 1, 4, 2. Okay, does 4 go into 16? It does. Greatest common factor. So I put my 4 here, parentheses. How many times does 4 go into 16? 4 times. Plus, how many times does 4 go into 4? 1. And the x goes with it. Okay? So it's 4 plus 1x times 4. Now, because it's 1x, I don't really need that. It's assumed just because it's x means there's an x means there's 1. Okay? So 4 times 4 is 16. 4 times x is 4x. I factored it out. Okay. Let's do one more. We have 36x plus 30. So I take my smaller number, 30, and I do my factors. 1, 30, 2, 15, 3, 10, 4, no, 5, 6. Okay, there we go. Now, does 30 go into 36? Does 15 go into 36? No. Does 10 go into 36? No. Does 6 go into 36? Yes. So I have my 6 here. How many times does 6 go into 36? 6 times. The x has to go with it. Plus, how many times does 6 go into 30? 5 times. Okay. Once you get it this far, then it's always important to check it using the distributive property to make sure you got it right. 6 times 6x, 36x, plus 6 times 5, 30. You got it. Okay? Please double check your work, take your time, factor things out. And really, the distributive property is so important to know. It's so important to know that you're going to distribute this to here and then to here. Okay? All right. Go ahead and watch the guided practice, then independent practice, and so on. Let me know if you have any questions.